on, and we are focused on AI today. So it makes sense to start with a presentation from a leader of the most valuable company in the world and the leading semiconductor supplier to the AI community, NVIDIA. Dr. Timothy Costa, General Manager, Industrial and Computational Engineering at NVIDIA, spearheads the strategic development and implementation of solutions for critical industries, including semiconductors. He leads the industrial engineering and quantum verticals, as well as responsibility for the CUDA-X product line. Thank you, Tim.
All right. How's my mic? Everyone can hear me? Great. So thank you to the organizers, to all of you for being here, to all the other great speakers who've made this a wonderful event. We are going to need all of 25 minutes to get through this presentation, so I won't belabor that too much longer. I'm here to talk about AI supercomputing for next-generation semiconductor design and manufacturing. That is a mouthful. So I think if we were to kind of summarize what we want to talk about here, it's really the virtuous cycle between AI and the superconducting industry. This is all possible with NVIDIA PhysicsNeMo. This is our framework for AI physics. It starts as a highly GPU-optimized PyTorch. It's fully open source. And what we add on top of PyTorch is some APIs and features to enforce physics constraints into the models that are being trained. The result of that is you get a more accurate model, and because it's highly GPU optimized, you get great performance on NVIDIA hardware. But at its core, this is PyTorch. So if you're comfortable using PyTorch, you'll be comfortable using PhysicsNeMo. Let's play the video.
The world is racing to build state-of-the-art, large-scale AI factories. Bringing up an AI gigafactory is an extraordinary feat of engineering, requiring tens of thousands of workers, from suppliers, architects, contractors, and engineers, to build, ship, and assemble nearly 5 billion components and over 200,000 miles of fiber, nearly the distance from the Earth to the Moon. The NVIDIA Omniverse Blueprint for AI Factory Digital Twins enables us to design and optimize these AI factories long before physical construction starts. Here, NVIDIA engineers use the blueprint to plan a 1 gigawatt AI factory, integrating 3D and layout data of the latest NVIDIA DGX SuperPods and advanced power and cooling systems from Vertiv and Schneider Electric, and optimized topology from NVIDIA Air, a framework for simulating network logic, layout, and protocols. This work is traditionally done in silos. The Omniverse Blueprint lets our engineering teams work in parallel and collaboratively, letting us explore various configurations to maximizing TCO and power usage effectiveness. NVIDIA uses Cadence Reality Digital Twin, accelerated by CUDA and Omniverse libraries, to simulate air and liquid cooling systems. And Schneider Electric with ETAP, an application to simulate power block efficiency and reliability. Real-time simulation lets us iterate and run large-scale what-if scenarios in seconds versus hours. We use the digital twin to communicate instructions to the large body of teams and suppliers, reducing execution errors and accelerating time to bring up. And when planning for retrofits or upgrades, we can easily test and simulate cost and downtime, ensuring a future-proof AI factory.
All right. So we have 1 minute left, which is perfect, as it's wrap-up time. So to wrap up, the semiconductor ecosystem is at the start of a new industrial revolution. There are $2 trillion opportunities in front of us, one presented to us by AI factories, and the other in physical AI. To capture those opportunities, innovation is required across many parts of the semiconductor design and manufacturing workloads, and AI supercomputing and accelerated computing is here to help. From accelerated computing for semiconductor design and manufacturing applications, agentic AI to increase the capability of semiconductor engineers, factory digital twins to automate fabs, robotics in those fabs, and vision AI for problems like mask and wafer inspection. AI and accelerated computing is ready to help across all these areas. And of course, this is done as a partnership with the ecosystem. We're a part of this ecosystem, and so we're thrilled to capture this opportunity together. Thank you.